Okay.
Hold on. Let me figure out the best thing to do. All right. Let's draw the circle. There's that tangent line. It's the diameter. And, oops, I drew that line wrong. It's got to go to the center of the circle. Alright, the only other line missing is right there. Now, let's label some of this stuff. Measurement of BC is 110 degrees. So this is 110. Measurement of EFA is 95. EFA, this is 95 right there.
Okay.
And the measurement of COD is 75. So that's all the information that we have. So for starters, let's write some other stuff down. What's DC?
DC?
What's the measurement of that arc?
It's 75 times 2, right?
It's just 75. In other words,
Just 75?
whenever you have a central angle, the central angle always cuts out an arc of equal measurement. So that is also 75 degrees. In fact, let's review that rule. If I have a central angle that's 30, this is 30. If I have an angle that starts on the circumference of the circle, then it's half. This has to be 15.
Yeah, that's where I was confused.
Right. So everything matters whether it's coming from the center or from the circumference. Okay. And then we have other rules that say that if you have two intersecting, this angle right here, which is the same as this one, is equal to this arc plus that arc divided by 2. Okay, so those are your primary rules that are going to affect our answers here. So we figured out DC, we figured out CB. Let's see. Now let's go back and see what they want. They want the measurement of AB. Well, let's see. I know this angle right here that's at F.
Yeah.
What is this angle right here?
Is it
How do you subtract from 180?
Is it
What's the
95 minus 180?
No, it's 180 minus 95.
Oh, yeah.
But remember, the first digit and 9 have to add up to 17, not 18.
Yeah. So 85?
There you go. I know we did a whole session on that one night, and you had it down pat by the time we were done. You were very good. You were very good at subtracting numbers from 180, which is a good talent to have. Okay?
Yeah.
So now we're looking at the situation where we have two chords, AC and EB. So this angle right there has to equal half of EC plus AB. We don't know what ED is, though.
Yeah.
Ah, yes we do. What's this angle right here?
180?
No. This angle right here? Supplementary with 75 because it's a straight line?
75 too?
No. In other words, you have a straight line with these two angles are always supplementary.
Okay.
That one's 75. This one has to be 105.
Oh, alright.
Okay, so this is 105.
Okay.
Now that tells us what AD is. AD is 105.
Yeah.
Ah, that's valuable.
Yeah.
Why? Because we know AD, we know DC, and we know CB. The only thing left on that circumference is AB. What do all four of them have to total?
360.
Okay, what do these three total?
290?
290, which means this has to be 70.
Yeah.
So
what about AE though?
Well, I don't care what AE is. Not yet. They may ask it, but I do know what AD is. In other words, all the way from this point at A around to D has to be this 105 degrees.
Yeah, okay.
Okay, and then I go from D to C, and then I go from C to B. The only thing left is AB. So
okay.
I don't have to know AE yet, which is good because I don't know what it is yet.
Yeah, okay.
But so I don't need to know it for this problem here. So the measurement of AB is 70. Next thing they want to know is the measurement of BCF.
Okay.
This angle right here.
Okay.
What is that? In other words, I'll make a check mark. That angle right there.
Alright, so
remember, this is the situation where you don't have a central angle subtending an arc. You have this kind of thing going on, where I know the measurement of the arc. So what's that angle?
35.
You got it.
All right, that's easy.
Yes, it is. Once you get the hang of these, they are pretty easy. It's just a question of going through each one and labeling it. So that's 35.
Yeah.
All right, let's see what else they want to know. BFC.
Okay.
In other words, this one here.
All right.
Well, I know that. If I know this one's 85, what's BFC? Well, in fact, I know this one's 95. What is that?
95 too?
Uh-huh. So that's 95. And now let's complete that triangle, because we have two angles of that triangle.
Yeah.
So 35 and 95 add to 130. This one's got to be 50.
50, yeah.
And now we know what ED is. Right? In other words, look at EBC is 50, which means the arc...
100?
Right.
Okay.
From E to C is 100, which means from E to D has to be 25.
All right.
Okay. So let's see, what else? We've answered that one. The measurement of AE. Well, I know AD is 105. ED is 25. So what's the measurement of AE?
125?
No, it would be 105 minus 25. In other words, my 105 here is from A to D. Well, we now know from E to D is 25.
Minus 25?
So 80.
Yeah, 80.
This one is A to E is 80. Okay, next one. Measurement of CBF. CBF. Well, we figured that out already. That's that angle right there, 50 degrees.
Okay.
Okay. And the measurement of EFC. That's this angle right here. Well, what is that angle right there?
Is it 85?
It's a vertical angle with this 85. So it's 85. It's also supplementary with the 95s.
Yeah.
Okay. And the measurement, finally, the last question is the measurement of DE. We already figured that out, 25. So we answered all of it. And that's not a bad process to go through.
Yeah.
Just the way we did it right there. And you can see that would have been hard to do without drawing it and labeling everything.
Yeah.
And that's going to be if you get a problem like this on the test, well, hopefully you'll be able to draw on the test. In other words, it's going to save you a lot of time if you don't have to redraw this thing. You know what I'm saying?
Yeah.
But the key thing on all of these problems is to label everything they give you and then just start figuring out stuff. And you don't even have to do it in the order they ask. In other words, it can be a little difficult sometimes to do it in the order they ask because you have to figure out something else before you can figure out that. You know what I'm saying?
Yeah.
So the best thing to do is to take your picture and fill in as much of it as you can without even looking at the questions, and then do it the other way. In other words, do the questions based on your figure. All right. Let's go to the next problem. What happened to 2, 3, and 4? This was problem 1. Next one is 5. Did I miss some?
Did you not get 2, 3, and 4 the worksheet?
I got a second worksheet here. Let's see if 2, 3, and 4 are on that. Yeah, they are. Okay.
Yeah.
Oh my God. Yikes. Okay. Well, let's do another one.
Alright.
I don't know how else to do. These are hard, but the only way to do them is to draw them, and I'm going to let you label them. Okay?
Alright.
So, make a bigger circle this time. Hold on, let's see. These intersect outside of the circle. Wow. Not that easy to even draw.
Yeah.
Wow. All right. That's L. This is T. O. The center of a circle is always O. I didn't get the rest of it right, though. Here, hold on. Let's see. That has to go all the way to there. And this thing intersects it. Let's see. It's got to go through L. It's got to go through M. Like that. Okay. This is N. That's R. All right. Do we have the picture drawn right? I think we do.
Yeah.
Okay, now let's label it. OT is an angle bisector of LOQ. So this angle equals this angle. We'll just label it with an X for the moment.
Alright.
What does this say? MLQ is 100?
Yeah. MLQ is 100, yeah.
Well, that's not even on our picture, though. What does that say in back of that? Is that an L or an E? Is that MLQ?
Yeah, it's an L.
L. So
MLQ, yeah.
All right, well, we're going to have to draw that line in.
All right.
There's Q. Oh, my goodness. This whole angle is 100. Wow. That seems weird. That line was not drawn on their diagram.
Yeah, that is weird.
Okay. M-O-N is 20. This one's 20.
Okay.
Okay. Is that all?
Right.
That's all of our information.
Yeah.
All right. Well, I'm thinking about how to go about doing this. Good grief. Well, first thing they want is the measurement of LOQ. LOQ, which is 2x. But we can't give that answer.
Okay.
Well, let's see. We know what this degree measurement is we know what MQ is. MQ, the arc, is what? Based on this 100-degree angle up here.
200?
Uh-huh.
Okay.
So we'll write that.
Okay.
What's the measurement of MN arc?
MN?
MN. This little small one.
Is it?
Remember, it's coming from a central angle.
It's 22?
20. Okay.
All right.
If MQ is 200 and MN is 20, then QN has to be 180.
Yeah.
Well, that's very helpful because that tells us what this angle is. What's this?
Is that 182?
Yeah. Now, let's see. What else they want? I'm still questioning this MLQ here.
That's weird.
Well, it's not only weird, but it doesn't fit the diagram. Notice that if I draw a line from L to Q, that angle is less than a right angle. It's not 100 degrees.
Yeah.
Not that that necessarily matters, but it makes me almost think that that's a typo.
Yeah.
Or it means something else. You know, in L, M, L, O, that's not 100 either. I don't see any 100-degree angles in there, unless that would be the 100-degree angle. Let's see. The measurement of NQ. We'll leave that first one blank for a moment. LOQ. Can we figure out LOQ? We don't know this angle yet. If we knew that angle, why would that be 180? MOL.
Because it's opposite from QN. Well, no, it's not opposite. Never mind.
Let me think for a second. I want the measurements of NQ. Well, we got that. It's 180.
Yeah.
So we know how to answer B. Let's just keep going until we find one we don't know how to answer. What's the measurement of NQO? NQO, this angle right here.
Okay.
Wow. We got a problem already. We got a big problem already.
What?
That angle can't be 180.
Yeah.
Otherwise, it would be a semi. In other words, you're not going to be able to form a triangle, right? If this is 180, these have to be something. There's going to be more than that. So let's see. That leads me to believe that that's a typo even more.
Yeah.
NOQ has to be the measurement of the arc NQ. This arc was 20 degrees.
Yeah.
Oh, I see what's going on. No, I don't. I dropped that line from L to Q that's not in your picture.
Yeah.
That's the angle that they're telling us was 100 degrees. That can't be.
Yeah.
Because if MLQ is 100, then arc Q to M is subtended by that, right? In other words, L goes to there, and then it goes to here. So if that's 100 degrees, this has to be a 200-degree arc. That is 20 for sure.
Yeah.
Which would leave only 180 for this, which would make that 180, which is impossible. So
I feel like there's definitely a typo.
what a cruel thing to do.
Especially on the final review.
Well, it's just cruel because these take 20 minutes to do.
Yeah.
And if there's a typo in there, that's not hardly fair.
Yeah.
This arc is definitely 20 degrees because they say that angle is 20 degrees.
Yeah.
I don't know. Let's go on. Instead of spending our entire session, if there's a typo.
Yeah, I agree.
I'll look a little bit more at it before our Wednesday session and see if I can figure out what the heck's going on because their information, this part right here is the typo. There's no way that MLQ can be 100 because that would make QM 200. And that would make QN 180, and that would make this angle 180. And yet there's a triangle there. There's no way that's a 180-degree angle. For that matter, there's no way that QN is 180. It's less than half of a circumference. Yeah, that's the typo there. Question is, what should it read? And I can barely read it as it is. Because this little square that is stuck in there kind of makes that L look like an E, but there's no E.
Yeah, I don't know what that square is there.
Yeah, that's a typo there. That's not 100 degrees.
Yeah.
And it can't be. All right, we can't solve it if there's a typo, so we'll go on. Fill in the blank to complete the theorem that applies to this diagram. What the heck does that mean? M is less than ABC.
if and only if AC is a what?
Okay. What this is supposed to say is the measurement of angle ABC. In other words, it should be written like this. That makes me even more certain that the previous problem is a typo. And the fact that they use the less than sign instead of the angle sign. Right? That measurement of angle ABC is what? What goes in this blank right here?
It is 90.
Exactly. It's a triangle inscribed in a semicircle, right?
Yeah.
Okay, those are always 90 at the circumference. But if and only if AC is a what of the circle?
If and only if AC is a diameter?
Yeah. In other words, if I had a circle like this, and there's the center, and I put that triangle in there, that's not a 90-degree angle.
Yeah.
Because this is not a triangle inscribed in a semicircle. The only way it's a triangle inscribed in a semicircle is if AC is the diameter.
Yeah.
All right. So what do you suppose goes in those two blanks?
A quadrilateral can be inscribed in a circle if and only if.
Look at that quadrilateral and see if you can figure out what they're referring
to. Is it if opposite angles are equal?
I think that is it. Or is it adjacent angles are supplementary? In other words, this, does that look equal to, does D look equal to F? It doesn't to me.
No.
And G doesn't look equal to E.
Yeah.
But G looks slightly acute and F looks slightly obtuse. So F and G probably are supplementary. Let's see if we can figure out how to solve that for sure. Let's draw some quadrilaterals inside circles and make them shaped differently. In other words, rather than being shaped like your picture, I'm going to make it even more different so we'll be able to tell what those angles are. Because I quite honestly not sure what it is. But I'm going to draw a quadrilateral really strange. Now, are opposite angles equal?
No.
For sure not. There's no way that angle is equal to that angle.
Yeah.
So it's not opposite angles are equal. It's got to be adjacent angles are supplementary. In other words, this angle plus that angle adds to 180. This angle plus that angle adds to 180. That angle plus that angle adds to 180.
Yeah. Okay.
All right. So even if you forget the rule, you can still figure it out by just drawing a different picture. We couldn't really figure it out from this picture because all four angles were too equal to one another. Yeah. But by drawing a picture where I make obvious obtuse angles and obvious acute angles, I can solve it. It's clear that opposite angles are not equal. The only other thing that it could be would be adjacent angles or supplementary. All right, let's go down to the next one. reading it.
In the diagram below, the radius of the small circle is 2 inches and BC in the diameter. Also, AB is tangent to a small circle at point B. If MAD equals 85 and MAD equals 215, find MDE.
And the measurement of angle DAE.
Yeah.
All right. Well, I'm afraid I'm going to have to draw this one too in order to label it. I do hear a little static. That's better than you not being able to hear me at all.
Yeah.
Alright, that's A, that's D, that's E, that's B, that's C. 85 degrees is AD. AE is 215. What's that leave for DE? Let's go ahead and put it in there.
Is that
add 215 to 85, what do you get?
300?
Okay, that's the only...
That's 60 then, right?
Right. In other words, it has to total 360 around.
Yeah.
So that's 60. That tells us quite a bit. What's this angle?
That's 30.
Uh-huh. Is that one of their questions? DAE, yeah. So we got DAE. Oh, we got DE. That was quick. Wow. We didn't even have to look at this part of the picture. What's going on?
I don't know.
Seriously. I didn't consider... Oh, the area of triangle ABC. We do have to look at that. I didn't see this. I didn't see the last question. The area of the triangle ABC.
Okay.
What's this angle right here?
Which one?
That one. Angle ABC.
Is that 60?
No, what happens when a tangent line intersects with a diameter?
That makes a right angle.
Right, so that's 90.
Alright.
So that means that the area of this triangle is the base times the height.
Okay.
Let's see, the diagram below is the radius of the small circle is 2 inches, so BC is 4, right?
Yeah.
And what kind of triangle is ABC?
A right triangle?
It's not just a right triangle, it's a 30, 60, 90 right
30, 60, 90, yeah.
Okay, that's going to help a lot because we know that in our picture of a 30, 60, 90, this might be one of the things you want on your cue card.
Yeah.
Is to put these, both of them. That one right there, because what happens is that we're looking at our triangle ABC is similar to this triangle, right?
Yeah.
Has to be. It's got the same 3 angles, 30, 60, and 90. This is 30, 60, 90. The only difference is what's the scale factor? How much bigger is each side over here than in my unit one?
1/3?
No, BC is 4. This is 4. That's the small.
Okay.
That's the small side of that triangle.
So it's 4 to 1?
Right. In other words, BC is opposite the 30-degree angle.
Yeah, okay.
So opposite my 30-degree angle is 1, so the scale factor is 4 to 1. So what's the length of AB?
AB is, so
You have to find its equivalent side.
AB is the square root of 12?
Well, you're close. It's 4 square roots of 3, which is not the same thing as the square root of 12.
Oh, okay.
It's 4 times, right? And it's this side that's the equivalent side to AB.
Yeah.
The side opposite the 60-degree angle, which is right there.
Yeah.
Okay. So AB is 4 times root 3.
Okay.
Now I know my area. What's the area of that triangle? What's the formula for the area of a triangle?
Oh, God.
This is definitely one you need.
Length times width?
No, that's a rectangle.
Oh.
1/2 base times height.
Yeah, 1/2 base times height.
Think of a rectangle as being base times height. You said length times width, which is better to call it base and height. Okay?
Right.
Because if you take a rectangle and you split it up into triangles, every triangle is always half.
Yeah.
So if you remember the rectangle as base times height, you'll remember that the area of a triangle has to be half base times height. So, and as long as this is a right angle here at B, then I know what my base is and I know what my height is.
Yeah.
So plug it in. What do we got? The base is what?
The base is 4/3 pi.
4 root 3.
4 root 3, and
the height?
The height is 4.
All of that is equal to what? What is 1? I'm going to erase this 215. We don't need it anymore.
Okay.
What's that condensed to? Simplify to?
Alright, that simplifies to... I don't know.
Okay, well, let's go over that math there. We got 4 root 3 times 4 divided by 2.
Okay. So, is it 16 root 3 divided by 2?
Correct.
Is it 8 root 3?
Yep.
Okay.
Okay. All right. Let's have a look at, 5 is on the previous page. All right. Yeah, let's make sure you understand all these terms here.
Okay.
So, there's our circle. A secant line does what?
Goes on the outside of the circle?
Does that. There's a secant line.
Okay.
Okay. A chord does what? Here. Tell me if I have a chord on this thing. The secant line is AC.
Okay.
Is there a chord in there?
No.
There is. Any straight line that connects two different points from the circumference is a chord. So AB would be a chord.
Okay.
And what's a central angle? In fact, here I'm gonna draw a couple here.
Okay.
Define a central angle for me by letters.
AOB.
Define an inscribed angle for me.
OA.
OAB.
OAB.
OA is just a line, okay?
Okay.
So
yeah.
OAB gives this inscribed angle. In other words, inscribed means where one of the vertexes is on the edge of the circumference. Also, OBA is also an inscribed angle.
Okay.
I know you know what diameter is.
Yeah.
Tangent is what?
Tangent, it goes on the it touches the outside of the circle.
At how many points?
Just one.
That's the key part of the definition. It's only a tangent if it touches one part only. In other words,
okay.
That's not a tangent line.
Okay.
That one is not. Okay? Oh, chord again. There's all kinds of typos in this thing. And central angle we did. Okay. So let's go on to 6. Not sure we can do this in 4 minutes, but we can look at it. Okay. We got 2 circles down there. Which one can be labeled by which of these equations?
Okay, so
does circle A, is it on this page?
Circle A, no.
It is. What's unique about circle A is that the center is at the origin. Why? Because I don't have anything being subtracted from X and I don't have anything being subtracted from Y.
Yeah.
These represent the centers of those circles. So this is the only one that's at the origin. Well, that one's not at the origin, but that is. What's the radius of circle A?
0.
It's 3. The equation of a circle is x squared plus y squared equals r squared. Well, if we look at this, that's 3 units from there to there. So this circle is definitely circle A. This circle over here, where's its center? Relative to these numbers. You know that one of them has to be 4, one of them has to be 2.
Yeah. So
these must be 1, 2, 4. Okay, so the x-coordinate of the center of this circle is -4. Which equation is that?
The third one.
Good. Good. I thought you were going to say B for sure. No, you're right, because it's always x minus h. So because it says x plus 4, that means that h must be -4. And that's what h is there, is -4, and y is +2, and that's what that is right there. So that's circle C. Okay. Circle B is going to look just like that, only where's the center of circle B going to be?
At +4.
And what y coordinate?
+2.
No. -2.
Oh yeah, -2. I looked at the wrong one.
Right, it's always the opposite of that. So it would be this circle, because they both have the same radiuses, only it would be drawn over here.
Okay.
Okay? All right. And we can pick up with number 7 on Wednesday.
Okay.
All right. Good stuff. I don't know if
I can get my bottom computer my downstairs computer to work.
All right. Well, this works fine for me. I mean, I don't notice any difference, to be honest with you. But you might on your end. The other might work better for you on your end.
Yeah.
All right. I will talk to you. When is your next one? Wednesday at same time, 6 o'clock. Okay.
Okay.
See you then.
Thank you.
You're welcome. Bye-bye.